Greetings and welcome to PinballHelp. Mike here. Today I'm going to talk about how you can make a little MacGyver-esque test rig for certain system boards in the computer in order to be able to test things outside of the pinball machine. Why would you want to do that? Well, sometimes you're working on a board and you need to, you're doing something and you're checking it, and you're doing something and checking it, and putting it back and forth in the pinball machine and connecting all the connectors is a real pain in the butt. This allows you to work on the board on the bench, but also be able to supply power. And this is how most of the professional people do it, although they have official test rigs that are made by the pinball companies. Anyway, I'm going to show you a DIY way you can take a simple PC power supply and use it to provide certain power to these boards so you can test them. So what I'm working with here is, this is a Stern MPU 100. It is a copy of the famous Bally-35 board right here. And this is a very, very popular, very common board. What these boards need in order to be able to boot up is 12 volts and 5 volts. So we're going to get that off of the PC power supply, and I'm going to show you how you can do that. This will get us 6 of the 7 flashes on this board. And if you're familiar with this board, you know that when you're testing the game, you flip it on and you watch this LED, and it's supposed to flash 7 times, and that means everything is okay. We can get it to flash 6 times with the PC power supply. The reason why it won't flash the 7th time is because then it's looking for some other stuff like high voltage for the coils, which we're not supplying. But if you're testing this board, it's got battery damage, you're checking some components, this is a good way you can do it outside of the machine and get it all the way up to 6 flashes to make sure that everything is working before you throw it back in the game. So let's show you how this happens. Now, you can use an older PC power supply, and in some cases they're actually better because they're a little bit less complicated. This is an ATX power supply. It's one of the more common ones that you'll find right now. So the first thing you want to notice about these power supplies is some of them don't even have on-off switches. They're controlled with a switch from the computer that's connected in through this connector here. And let me undo what I've done already to show you what we will be doing. So this is your main connector that connects to the motherboard in there, and you'll find a green wire on it. See, I've actually pulled the wire out and stripped it, and then I've taken a black wire here, which is ground. So I've got the green and the black. This green is the power button for the computer. So what we're going to do is simulate this button being pushed in by grounding it. So we're going to ground the green to the black. Now, you could just strip them and connect them together like this. It's probably just as easy to do that. Although, if you have a power supply that doesn't have a switch on it, you might want to put a switch in there or use an alligator clip. I'll just do it like this for now. So we're tying the green wire to the black wire over there. Okay, so that's done. Now I have a switch on the back of mine, and I'll show you. Let's see, show you what happens when you see the fan now comes on. So we know this thing's powered up. If I disconnect those 2 wires, this thing will stop. Now you'll notice it started and then it stopped. Why did it stop? Because it doesn't sense a load on it, so it shuts down when it's not connected to anything. These switching power supplies have this feature where they won't waste their time and energy running if there's nothing that they need to power. This can be a problem if you're trying to check something that may be very low power and it might not have enough draw to keep this thing on, but I haven't run into a problem with these boards. Some power supplies may be a little bit more sensitive than others, so you'll just have to test it. So let's flip it back off, make sure it's off. Yes, okay. So now we need 5 volts and 12 volts in order to so I'm going to take this other big long string here, which has all these peripheral connectors. You'll recognize a lot of them. The most common peripheral connector is this guy right here. Your standard connector for CD-ROM drives and hard drives or whatever. I mean, now everything's serial ATA, but almost every computer will have at least 1 or more of these in it. So you see 4 wires, a yellow, 2 blacks, and a red. The yellow supplies plus 12 volts, the blacks are ground, and the red supplies positive 5 volts. So we are going to jump into this. There's a couple of ways we can do it. We can clip it, we can strip the thing, or you can just clip right onto the connector right there. So the first thing I want to do is let's run the ground, and to make things easier, I'm going to run a ground off of the same wire over here. Oops, I disconnected them. So let's see. Twist those two, clamp them together, and the ground is test point 4 on the board right there. So now I've got the black tied to that. So now we'll take the red and the yellow and connect into the red, and that's going to go to test point 5 right here. Think TP5, 5 volts. Think TP2, 12 volts. Of course, you always want to check just to make sure. Okay, so TP2 is right here. You want to be careful not to let it touch anything else. Okay, so there we go. We have everything connected for our test fixture. There's our LED right there. We've got 12 volts to TP2, we've got 5 volts to TP5, and we've got the ground. Okay, so let's switch it on. Pay close attention to this LED right here. Alright. I think one of the things may not be connected. Although we are getting it ground. Hold on a minute. Let's try something different. Alright. Maybe that ground over there is on a different circuit. So let's go to the ground over here. So I'm going to connect the ground to the black wire in the powertrain. That could be an issue. And I'm going to make sure everything is reseated properly. TP5 is to red, to yellow, and black to black. Okay, let's try that again. Here's our LED. Flip it on. Oops, now we're not getting anything. So one of these wires must not be making contact. Let's see. Yeah. Let's see which one it is. Never works right when the camera's on, huh? How do you like that? Okay. Everything's off. Oh, the power button was not connected. Okay, that helps. It helps if you do that. So it also helps if there's not a camera running when you're trying to do all this, because you get distracted trying to do this show. I would be much more conscientious if I wasn't trying to like teach and do it at the same time, but I come off like a moron, so I apologize. Alright. Check everything. It doesn't look good when you're just being methodical on camera. It's boring, but it's important to do that. Okay. Flip the switch. Blink. 2, 3, 4, 5, 6. And voila, there we have it. So we know this board is booting up as it's supposed to be. It's got power. We can use our meter here and connect up and show 5 volts and 12 volts at all the standard test points. So this is a great way of hooking things up to on the desk, on your bench, and being able to work on things. Obviously, I did this kind of haphazardly because I was trying to demo it quickly, but if you're setting up a bench at home, you want to be a little bit more methodical. Strip the wires, make them nicer, maybe put a little switch in there. Cut all, if you got a power supply you're going to throw away, cut all the other crap off and just, make it a neat little, cool looking little thing you can plug right into. You could even get a plug that would plug into one of these header things that would connect right into the PC thing. So there you have it, a little DIY test rig to check the game. So turn it off. For more, visit PinballHelp.com or see us on Facebook. Thanks for watching.